In this lesson, we are going to review a lot of the key concepts about linear equations. So let's start by looking at this concept web. One of the first places we begin when talking about linear equations is with slope. So let's do a little brainstorming about what do we know with slope? What letter do we use to represent it? Well, we've always used slope. Hopefully you know that slope is rise over run. It's also the change in y over the change in x, which that little triangle there means it's a Greek letter called delta. The formula for finding slope is y2 minus y1 over x2 minus x1, where you just have two ordered pairs. And a key concept is all linear equations have a constant rate of change, which is, of course, your slope. Right? Now, let's think about what types of equations are linear. What do they look like? Well, I'm going to go over here to this part of my concept web. Linear equations can be written in slope-intercept form. They're in the form y equals mx plus b. Some of the key ideas is that x and y will both be raised to the first power. So you might have y equals 5x. You could have just y equal to a constant, like y equals 2. You could have y equals 7x minus 3.1. You could have decimals and so forth. Sometimes it'll even be masqueraded in a different form, like x plus 2y equals negative 1/3. Now, nonlinear would be like this, where we have exponents on our variables. So over here, x and y are to the first power. One that's a little bit deceiving is y equals 4 over x. Now it looks like they're both to the first power, but x is actually to the negative first power because it's down in, it would have been down in the bottom to become positive. So this is nonlinear. If you had y equals x to the third or x times y equals 7, that's also nonlinear. Which now leads me into slope-intercept form, which is my personal favorite form of a line. And I did mention it already. It's when we have an equation where it's y equals mx plus b, where m is known as your slope, as we already talked about, and b is your y-intercept, place where it crosses the y-axis. So an example to show you would be y equals negative 5/4 x plus 10. So m is negative 5/4 and b is positive 10. With an equation like that in slope-intercept form, we can graph it, we can make a table of it. I'm going to use this equation and look at what the table would be like. To forgive some of my shaky camera moves. So, an xy table, well, x is your independent variable, which is your domain values. You just select some values and plug it into the function to get y. So when I plug in 0 for x, I would get 10 for y. When I plug in 1 for x, I'm going to get 8.75. When I plug in 4, let's see, I toss out my calculator, I get 5. These are just 3 ordered pairs that fall on this line. There's an infinite amount of ordered pairs that would fall on this line. I could just keep picking any value I wanted for x and plugging it in to get y. Another form of linear equations that we've dealt with would be standard form. So standard form looks like this. It's where you have ax plus by equals c. Technically, a, b, and c can't be fractions, and a and b can't both be 0. When I'm standard form. It's easy to find the x and the y-intercepts, the spots where it crosses the x and the y-axis. So let's say I have the equation 5x plus 4y equals 40. To find an x-intercept, well, this is where your graph crosses the x-axis. So y is always going to be 0. So we let y be 0 to get an x-intercept. When I do that, the nice thing is, if y is 0, this just disappears. So it's like cover up the y, and I get 5x equals 40, and that's super easy to solve. I would just divide both sides by 5, and I get x equals 8. So my x-intercept would be an ordered pair. X is 8, and we said we let y be 0. The y-intercept, well, we let x be 0 for the y-intercept. So it's as if I just cover up x this time, which produces 4y equals 40. Super easy, divide by 4, and I get y is 10. So my ordered pair here is 0, 10 for the y-intercept. So let's go and graph this. So I have the equation in both slope-intercept and standard form with my intercepts. I just saw that my intercepts were 8, 0, so I could go over to 8 on the x-axis and up to 10 on the y-axis, and I can connect it with a line. And I'm going to put arrows on either end to indicate that it keeps going. Now, if I had done this from slope-intercept form, which was y equals negative 5/4 x plus 10, I would begin here by plotting the y-intercept first, which is right here, and counting my slope of negative 5/4, where I go down 5, right 4. So you'd go down 1, 2, 3, 4, 5, and right 1, 2, 3, 4, and here's another point. If you do it again, you would land on top of this one, and you see you get the exact same line. Final thing I want to look at right now with you is verbal descriptions. So it says a bus pass can be purchased for $10. Each ride deducts $1.25 from the pass. Create a linear equation to represent the number of bus rides and the value of the pass. So as I think about this, I begin with $10, and I am riding the bus multiple times. Each time I ride, it deducts, so it drops minus $1.25 per ride. So this right here would be number of rides, and that's going to equal the value of the bus pass, which I'll call Y. Now, I just threw a lot at you. I realized that was 8 minutes, but that was almost an entire unit back in Algebra 1. So I would encourage you to rewatch small portions of this if you need to. We're now going to do a few practice problems. Here we are given 3 tables, and it says, which table shows a non-linear function? So what we're going to do is we use the idea that we need a constant rate of change, which means between any 2 points, the slope has to be identical. So what I do is I first calculate, I look at my x's, and I see, okay, it's going up by 10, and up by 10 consistently on each of these. Whereas the y's goes up by 8, again up by 8, and again up by 8. So my change in y is 8, and my change in x is 10, meaning my slope is 8/10 or 4/5, and it's constant. So this one is linear. And I check the next one. This one is going, let's see, up by 6, again up by 6, and again up by 6. So my change in x, my bottom value, would be 6. Let's check our change in y. This goes up by 4, again 4, and again 4. So my slope is 4/6, or 2/3. So it's constant, so this one is also linear. So it must be my third one that's not linear, but let's actually identify it. So as I look at the x's, it's going up by 5, up by 7, and then up by 1. So I already see there's some strange values, but you still should check your y, because it's possible that they're just giving you weird points and you've got to check in between just each pair. But my change in y here goes up by 9, up by 3, and up by 1. So in between any two ordered pairs, the slope is not constant, so C is nonlinear. I would like you to pause this one and see if you can count the slope of these lines. Press play when you are ready. Okay, so line J, first of all, remember that slope can be positive, negative, 0, or undefined. So J, choose 2 points where it's hitting in the corners. So it looks like I'm just going to exaggerate them. It goes down 1 unit and right 1, 2, 3. So my slope is -1/3. You can always check that. Remember, you can choose 2 points that are further apart. You could always choose these two and count down 1, 2, right? 1, 2, 3, 4, 5, 6. Well, -2/6 would reduce to -1/3. All right, line K, the blue line. So I find any 2 points. I'm going to go with these two. My rise is up 2. So my top number is 2, right 1. And they're both in the positive direction, so my slope is 2/1 or just 2. Line N is my vertical line. So if I choose any 2 points on here, if I choose these two, my vertical change, I could say it goes down 3, so I could make it -3 divided by 0. Well, if you try that on your calculator, you'll see this is undefined. You cannot divide by 0. Hopefully you remembered that one, that vertical lines are always undefined, which leaves the green line, line P. This one has a slope of 0. It's completely horizontal. You could just choose 2 points. So this goes over 1, 2, 3, 4, but the vertical is 0, so 0/4 reduces to 0. Here's a word problem from Get More Math. Gotta love these. Farmer Ellentine with friends. Who knows what a friend is? I don't. Farmer Ellentine started with some friends on her farm. After 12 days, she had 61 friends. So I would call that an ordered pair. 12 days, 61 friends. After 15 days, she had 73 friends. Assume a constant rate of change. So to find our rate of change, we're going to do m is equal to y2 minus y1 over x2 minus x1. And you're going to substitute. Does not matter which one you call 0.1 and which one you call 0.2. All right, so the way I have them numbered, this would be 73 minus 61 over 15 minus 12, which gives me 12/3, or a slope equal to 4. This would be a pretty steep line. All right, let's do another reminder on graphing. So my slope here is -2/3, and my y-intercept is 2. So I begin by placing 2 on the y-axis, and I count down 2, right 3. Put a point. Count again, down 2, right 3. Keep going until you reach the edge of your coordinate plane. Now to back up the other direction, you could go up 2, left 3, and place a point. Up 2, left 3, up 2, left 3. And then rule of thumb is you draw a great diagonal line through those points, and it should be, like the same size of your coordinate plane. Here's an equation that's in standard form, so I'm going to go with finding my x-intercepts, which means I cover up y, If I cover up y, I would get 2x equals 10. Divide by 2, and I get x is 5. So as an ordered pair, that would be 5, 0, because this is in the x spot. Put my point. To find my y intercept, I cover up x. Cover up x, which gives me negative 4y equals 10. So divide both sides by negative 4, and I get that y is negative 5 halves. So my ordered pair would be 0, negative 5 halves. Now when you go to graph negative 5 halves, that would be in decimal form negative 2.5. So negative 2.5 is right there, and I connect it to make a beautiful line. Now, if you don't, I do expect you to know standard form and how to find your x and y intercepts, but you could always solve for y and graph it in slope-intercept form if that's your preference. So hopefully this is a good review for you, and it's not all brand new content. You just needed a refresher to bring this back to your memory. It's time for you to do some practice to get really good at this.